With the last sessions. So we are started practicing with the system design. So let's continue that. So in the last sessions, we have been completed with the two micro questions of related to system design. And now we are continuing with the second session. So let's just check mic testing is audible properly. Micro questions of related to system design. And now, yeah, the audio is audible clearly. Let's start our sessions and let's practice our questions that are remaining that we started yesterday. Okay, so let's just increase the voice full max. Okay, the voice has been completed. So let's see the next system design question, which is the load balancer scalability. Okay, let's see the problem. You have a three identical backend server running. You need an engine that distributes incoming traffic equally across them. No single server get overwhelmed. Okay, understood. Build a round robin load balancer classes. Oh, round robin. Uh, did you remember the round robin concept? I didn't remember the exact things, but we all have been uh, read about it and write in the answer sheet about this round robin. In the operating system, we have a concept there. We have been explained how the round robin works and it's happened. So if you know about that, share with your data, your knowledge in the comment section. We will love to see that about the round robin. So yeah, this was all the things that are related to the software development, life cycles, and other the things which is essentials for the software engineer. So we are targeting the system design, and today we are practicing a balancer also with a most interesting concept of a round robin concept in the OS also. So now let's see how it's performed. We will be uh, taking a demonstrations of a live demonstrations. Let's see requirement. The constructor accepts. Okay, let's create first a class round robin. Yeah, a round robin. Okay, round robin class has been created. It has a constructor. Always remember, you have a constructor. Even you are not creating a constructor in the class, but there is always a default constructor presence there. Accepts the array of a server. Okay, we have to accept an array which has a server1.com. After that, we have a server2.com. Apart from this, we are also having server3.com. Okay, so we have an array in the constructor. What we have to do? Accepts an array of a server's URL. Okay, let's create a this dot server equals to. Should we store in differently or together as a array? Let because they didn't mention anything. The constructor accepts an array of server URLs. Uh, let's for now name as a array of server link. Let's create like this. Okay, and while creating, let r1 equals to new round robin. In that we can pass this. So let's array of server link. Sorry, so let's server link equals list dot server link. We have accepted the arrays of server link. After this, we have a private state, which is the concept of encapsulation. So let's create a private variable index. Starts from 0. Got it? We have a public method also, async route request. Okay, we have async route request. What is the working of it? Return the server URL at the current index. Okay, current index is 0, so we have to return First, understand what is the full information we have been given. Return the server URL at the current index, then increment the index by 1. If the index reaches the end of the array, it must reset back to the 0 using the reminder operator. Okay, so we have to use the reminder operator. So the system design goal is learn horizontal scaling traffic distribution math. Okay, so here one more concept has been arrived is like a horizontal scaling. In the system design, we have a horizontal scaling concept, which means to grow your server in as a horizontal way. Okay, someone has commented us. Ayush Raj. Hello. Okay. Hello, buddy. Link ना है zero से कैसे zero? First of all, you can in the today's the Ayush today's world of the coding, you can either learn from the AI and the free of cost. You just tell like we are also doing the same thing. We are learning from the AI rather than you can pay to others or course. If you want a community where you can practice together, you can join some course or free course. You have a lot of option, or you can try with YouTube videos. But what will I recommend is first give a 1 week practice sessions with AI. Ask AI, give me some practice basic questions and teach me how I can learn. Make sure you add a concept, teach me like eli5 which helps us to explain the concept in assuming that you are a 5 year old, so it will be easy to easily explain you the concept with giving the examples that you are relative you can easily relate it. So you can try with that and practice with that and learn that coding easily. So AI is the most important aspect, essential aspect that you have free of cost. You can learn with ChatGPT, Claude, and enhance your coding skill. So we are also here practicing the system design concept through AI. So we are asking AI to give us a small questions, micro questions. So we practice about that questions and master the concept. Either you can do this or you can go with a YouTube. YouTube as a full source of structure, or you can have a platform like Stack Overflow, Gigs for Gigs, like the traditional method you can learn. There also you have lots of concept and learning by self thing. Apart from that, you can also learn from a great YouTubers and their courses from. They are teaching brilliantly. I have also experienced that courses and YouTube thing, and now I'm self-learning and self-practicing. The one of the most important aspect of learning is the self-learning. So join us, join our community too. In the YouTube community, we have a there a post section. You can post your questions and share your learning journey too. So we will be encourage you and let's learn together. So that's all I have think. If you have anything else, we will love to see your comment. Thank you, Aish, for commenting. So let's back to the our questions. So we have a round robin questions in the system design. So we will be learning here in this question about the round robin, how it's working, how the load balancer things works in the actual system, actual server, and learn about horizontal scaling also. Yeah, love to see your comment, Ayush. Okay, so let's move forward. Uh, the constructor accept an array of a server's a URL. Okay, the method. So return the server URL at the current index. Then increment the index by 1 if the index reach the end of the array. So let's check if the what will be if the index reaches index. What we have to see the current index, right? Current index. Check this dot. So accessing the private variable, remember use to hashtag current index is equals to what it is about. If the index reaches the end of the array. Okay, so we have to use this dot link server link dot length end of the array, which means I think -1 we will be using. Okay, because this is representing the array that we have been receiving from here. Okay, and this targeting the array, and array dot length, which is actual what is the size 0 1 2 3. This is a 3, length of is 3. So which means we have to come here, and when it will be come here, so will be -1 because the length is always count as 1 2 3, but our index is count as 0 1 2, like this. Yeah. So let's move further. What we have, if the index reaches the end of the array, it means it's reset back to 0. Okay, so this dot hashtag current index equals to 0 using the reminder operator. Okay. How do we using reminder operator? It's little tricky. What we can do is divide server link dot length module, which is so how it will be performing. Let's see. So it will be 3. Let's create the accelerator. So for understanding accelerator, so how it's going to work is here we have, so we will be have 3 here and here, right? And so this is the 3 module will be reminder, like this is a reminder what we will get. So we have to use current index. So first of all, the current index will be the 0. After that we have to do certain thing. If the is 0, then the index reaches the end of the array. Okay, it must be reset back to 0. Done. Using the reminder, not using this. Okay. Uh, Module this dot server link dot length. So what will we do? Say now its value is here also 3 and here also 3. So 3 divided by 3, you can say 3 divided by 3 ones are 3. So here come the 3 and here the modulus is 0. So yeah, this is the thing that we have to do. Y equals to let's module and equals to I think here equals to, so it will be just stored in the rather than doing this, let's be clear because it will create a confusion later. Okay, so we have been done here. It's in small and see, yeah, it's okay. After that, what we have to do is 0 modulus after return the server. If the index reaches the end of the array, it must reset back to the 0 using the reminder operator. Done. Returns the server URL at the current index. Current index. Okay. Let current IDX equals to this dot hashtag current index. So we are using because we are resetting here, right? So we can forgot that. So if we don't want to forget, so what we can do is storing in the external variable, extra variable. Okay, current index then increment by the x. Okay, so this dot hashtag current index plus plus. Either we can do is plus equals to 1 or plus plus, both you can do it. The meaning remains same. Okay, increment current index then increment the, okay. So after that, let's return the server URL. Okay, current server URL. So we can return this dot server link, which is an array, and here you are adding current index. Okay, so I think it's completed. Let's check, are we satisfy all the conditions or not. Problem 3, round robin load balancer. So accept a constructor. Okay, arrays, we have been accepted. Private variable, this is whenever you create a private variable, this is a concept of encapsulation, which is one of the important pillar of the oops concept. Remember that. Okay, so I'm also remembering and understanding how it's working. And here we are created this is a public method, and like this private variable we can create also a private method also. Okay, so yeah, that's it, I think so. Let's check this out how it's running. Let's see, r1 equals to, okay, so what we can do is route r1 dot route request. Okay, this is some kind of a promise. Okay, a sync function run. So we are creating external functions to running the asynchronous JavaScript. Okay, run here route request, here await, and here let ens equals to async, and what we can do is console.log ens. Okay. And let's now run. Let's see what we got. Okay, the route request is not defined. Why? Route dot, okay, route dot request. Not the route. R1 dot route dot request. Server one. Okay, let's run again. Not like this. Okay, if we call multiple time, then what we can get is ENS2, ENS3, and let's check the ENS2, ENS3. So one server to server 3. Uh, let's call once again. Now we are calling it ANS4. Okay. Uh, let's see one more time, and it's undefined. Should it be one undefined? No, it should not be undefined. Let's see where we. Okay, I have to see this thing. Console.log this dot hashtag current index. Let's just check 2. Why is a 2 here? Uh, let's just check this. Okay, the calculation is coming 2. 4 after 4 mod 3. A little bit confused about here. What just happened here? But we can see. Uh, if it is 4, right? So for what is current dot index module? Current dot index module length, which is length is 3. Uh, length is 3, right? 3. Current index is kind of if conduct length minus 2. Uh, if length, then it's 0, right? Okay, now it's properly working because we are minusing that. It should be not minus, it should be length. Okay, we completed this question now. So here we have understood how the horizontal scaling traffic distributions math work. So it will reset back to 0. You can see whenever it's loaded. So after that it managed and again it's reset to 0. So if we don't run this, we can see 3. Okay. Just check again. Console dot log this dot hashtag current index. So you can see after its index, so it started from 0, right? So when it first request has come, so it added. Second request come, added. After third has become the 0. Yeah, because after that this there is a no meaning of that, which means it should be written 0. If the index reaches the end of the array, the reaches end of the array, this is the end of the array, which it must reset back to 0 using the reminder operator. Yeah. Mm, I think we have been completed and satisfy all the conditions. Right. Let's go to next question. Let's comment this out. Okay, after we are having level 4 question, which is retry orchestral idempotency, and resilience locked until you pass the level 1 and level 3. Okay, we have been past level 1, 2, 3, right? Let's move forward. This handles automated potential back of delays when processing failed. Okay. Uh, what is the question? Let's check the first. Give a check. Yep. Uh, this. Let's just check the round robin. Check the check this level 3 solution. Solution and review. Let's take a review from the excellent architecture. 9 out of 10. Oh, 9 out of 10. Why? What is the 1% we have wrong here? The algorithm optimization eliminating the if block. Okay, is eliminating something we doing wrong or somewhat. Plus equals to 1 if this is the length and this is. So this work completely fine. It misses the architectural trick of using the module operator for infinite index looping. The beauty of the reminder operator is that it's naturally wrap up numbers around without needing a conditional check. If you use it on every request, you index increment from 0 to 1 and 2 and automatically snap back to 0. Okay, so we don't also have to use the 0, I mean if route here. Okay, so we can like this assign server equals to, okay, they have been used like this. And for this, so this is the optimized version of our solution. What we can do is, rather than doing this thing, we can optimizely do is const assigned server equals to this dot server link is our array. So in that we are passing just this dot hashtag current index. Okay, so this is the optimized way. Let's learn how to create optimized solutions, scalable solutions in system design. So current index equals to, we're just doing shortcut thing, which is this dot hashtag current index plus 1 and module that this dot server length, okay, link dot length. Okay, so they are doing this together. So either you can do like this for the simplicity for understanding. So an optimized version is this, like directly collect what you have to return. So we have been collected here, and after that we have been increasing plus also, and it will be if check automatically swap if it is greater than, so that will be back to 0. Yeah, this is the optimized thing that we have learned now. Let's move forward with the next question. Let's comment this out. Now we are moving forward with the level 4 final system design boss. Okay, let's check how does boss operates here. The retry orchestra. Okay, orchestra. You have successfully constructed a resource allocator connection pool, a faulty tolerance shield, which is a circuit breaker, and the traffic distributor, the load balancer. These are the topics that we are learning about, the different types of server and the system design related concept. how we can resource allocator and a faulty tolerance field and a traffic distributor. This is a load balancer concept, circuit breaker, and a collection pool. These are the concepts of the system design. Now it's time to build a resilience engine, the retry orchestra with exponential backup. Okay, when the microservice talk to each other, quick network drops happen frequently. If a request fails, hitting it again instantly will likely cause another failure. Okay. Instead, professional system use exponential backoff if a request fail. Okay. Retry 1, wait 1 second. Retry 2, wait 2 second. And retry 3 will be wait 4 second. The wait time doubles with each failure to give the receiving server breathing room to recover. Okay. So we are creating exponential patching. This is a professional system. Let's understand how we are going to do this. We have our instructions. Okay. But we have to practice more about the system design because this is the concept, this is the subject which needs more detailed understanding and more practice and experience. So if we learn this, we can create absolutely perfect and optimized versions of the coding. And yeah, we will be surely creating our own community where we can practice and create some open source related thing. So support us and do a comment and share these videos with your friends so they can also know about this and connect us so we can spread to most people and learn about this. Okay. Mm, let's just check what else we can understand from the question is. Just a second. Okay. Let's move forward. You have a successful constructed. Okay. Now it's time to build a resilience engine. The retry orchestra with exponential backup. This is a question. The problem is when Microsoft talks to each other, quick network drops happen frequently. If a request fails, hitting it again instantly like cause another failure. Instead, professional system use exponential backoff. It is a request fails. Okay, retry 1, wait 1 second, retry 2, 2 second, and retry 3 will be the 4 second. Okay, let's move forward towards the instruction. Let's okay. Now we are fine. Create a class. We have created a class. Retry or chase. Okay, created a class. We have constructor. Don't forget about the constructor. Okay, and constructor accept a max retries. Okay, let accept a max retries. Yeah, max retries. This dot max retry tries equals to max retries. With the max retries using constructor example, we implement a public. Okay, let's have a public method which is the asynchronous method called execute with retry. So we are solving a level 4 of system design questions. So here we are practicing the system design question which helps us to improve our thinking capacity and understanding how we can code efficiently and optimizely. Okay, so comment the optimize. Let's see how are the peoples are watching and liking about this type of concept to learning. We will love to see that. Okay, executed resilience logic. Use a standard loop like for or while that runs up to max retry times. Okay, let's go with the for loop because it's a basic one and we are love to see this. Less than max retries. Okay, and I plus plus. So this is the basic for loop syntax. What is apart from this is okay inside the loop run await callback. Okay, await we have a API callback which are we receiving here. Okay, try run within a try and catch block. Okay, so let's do this try and catch catch, and here we are catching the error. Okay, so let's for loop. First, we have been create a for loop that runs at a max times. Okay, inside the loop, run the await within a catch try catch block. Okay, so what if the error got fails? It will be getting the error. Okay, let response equals to await. Okay, here we are doing this. After that, what we have can do is here try and check if it succeeds. Return response. Successful response. Okay, return the successful response. Okay, let's return the response only directly. After that, what we can say is catch error. If it catches an error, you can reach your maximum retry ceiling, exit the loop and throw. If you have reached your max entries, okay. So what we are doing is if it is reached, if it is reached, if you reach your max retries, if it is reached max retries, exit the loop and throw the error. Oh, but it's a problem here, I think so. It will be create a confusion because we are inside the loop we have been created try. Inside the loop, run await call. Okay. Within a try catch block. Okay. So here question has arrived. How we exit the loop? Let's just check and understand deeply and the problem statement. What we have been given here is if you have reached your max retries ceiling, okay, exit the loop and throw return operation failed permanently after the max retries. Otherwise, calculate the sleep delay time using the exponent formula. Okay, this is actually a next level question. Let's understand deeply little more. What we have to do is let's say this see it has a loop which is running. Here we have a loop like this. Okay, this will run at least max retries means 3 times. If the retry suppose we are passing the 3, it will be 0 to 2, 0 1 2, right? So first will be response return. I don't think so it works like this. Let's follow the questions again. Use a standard loop. We have created a execute with a retry. Okay, in that we have a fourth thing is resilence logic. Okay, use a standard loop that runs up to max retries time. Okay, we have then created a for loop which will be run until it's hit to the max retries. Okay, so after that what if it succeeds instantly return the response. Okay, if it is success which means it will be return which means execute. If you have reached your max retry ceiling, if it is retry which means max will be end here. uh okay, let's just understand little more focusly, which means it's ended here. If it is not, then it will fail. Okay, so what we'll do if it fails? So first of all, at the first count it will be not reach the directly 3 3. First it will be 1, right? First it will be the 0, and we will check if the reach your max retries. Otherwise, calculate the sleep delay time using the exponential formula. Mm, let's just understand deeply. What we can do is here is otherwise calculate the sleep delay time using the exponential formula. Let's just calculate the sleep functions here. Mm, Calculate the sleep delay time using the exponential formula, which is 1000 multiplied by current atom. Let expo equals to 1000 2 multiplied by current 2 multiplied by current attempt equals to 0, which is 1000 ms. Attempt 1 equals to 2000 ms, and attempt, oh, it's a little bit confusing. We have a standard loop here, right, for while loop that runs up to max retries times. Inside the loop wait the API call. Okay, inside that we have been called the API call in the try block. Inside the loop run await call back within a try catch block. Okay, we have been called inside a try back uh, try and catch block. Okay, here what else we have to do is it's succeed, it retain the response immediately. Okay, if it catches the error, so first we will check, let's check if you reach the max retry ceiling, which is max retry ceilings is if uh, I equals to what we will do is max retries, if I equals to max retries. I think so we can do is -1, because first will 0, I 0 equal checks no. If I, yeah, uh, rather than that, yeah, we can do right -1. That's for safety, because it will be 2 now. So when the 2 I equals to 2, it will be has means it has reached. Seal exit the loop and throw the error. So it will be throw new error. Okay, throw new error. Throw new error equals to, let's just copy this, paste. Okay, operation fail permanently after max retries. Okay, so it will be done. Okay, otherwise what it will do, otherwise calculate the delay time using the exponent formula. 1000 into what is how we can find out this exponential thing. This is a challenge, a new challenge for us. Attempt 1. Okay, so here we have to create a let attempt. I don't think so attempt here will be, it will be loop continue, so again it will be create a new attempt, right? Let create a let attempt outside the loop only. 0. Okay, attempt 0 equals to 1000 ms. Okay, current attempt into the current attempt, 1000 into 2 raised to current attempt. It's little bit confusing. Log out attempt access failed, backing off. Okay, pause the execution line for the durations for using a set timeout promise wrapper. Okay, how the test case has been doing. Now failure count equals to 0. To test this, copy and paste the custom fail counter callback. Any instantative your orchestra run wait engine dot, okay, we are using this thing. and watches the console pauses sequentially 1 second and 2 seconds. Okay, understood. We have to pass this callback, API callback. Okay, what we can do is, okay, we have been called this try catch error. If error, okay, it will be do like this. But we are not creating attempt here. Okay, if attempt is equals to was 0, so what will we do is mm, hmm, how do we figure this out? We have to just figure out this out. So we'll be completing our question. It's an important thing. It's calculate the sleep delay time to using the exponential function. How to use exponential function? Do we have exponential method in JS? Uh, yes. Okay. How do we exponential? 2 int. Okay. This is the operator, exponential operator we can use, or we can use the mac dot power. Let's use this mac dot power. But how we are going to use 1000 into 2 into math dot power, which is 2 comma math dot power 2 comma current attempt 0. First it will be attempt 0 is 1000 ms, attempt 2 is 2000 ms. So how it's going to come 1000 and 2000 ms? Okay, let's create this 1000 only for now. Attempt. Okay, once it's 1000 it will be like we have question 1 second. 1000 into 2. Hmm. Back exponential function, right? You request wait for 1 second. 1000 into max attempt is 0. 2 raised to 0 is 1. Okay, so it will be like 0 only. 2 raised to 0. First attempt is like this. 2 raised to 0, which means 1. So first is second. After that 2 raised to 1, which is 1, so which is with 2. 2 to the 4. After that is 2 raised to 2, which means uh, 2 times 2, 2 to the 4, which means we 4000 multiply by. Okay, we just solve this thing. Okay, understood. Figured it out. What we have to do is here. Okay, uh, log out. We have to do the log out thing. Log out. Let's console.log backtick here, and what we can see is attempt, not here, uh, attempt x, attempt here, attempt attmt attempt failed, comma backing off for y. What is y here? X is I got attempt x failed and backing off. I think here it will become as a I, right? I think so. Backing of I for ms, or I think so backing of yms instead of y, it is about x for ms. I think so because it's a time, right? Pause execution inline for duration using set timeout promise wrapper. Pause execution. Pause the execution. We have to pause the execution inline for the duration using a set timeout promise wrapper. What we have to do is pause the inline executions for the duration using a set timeout promise wrapper. Wrapper. Why the hell is wrapper is here? Mm-mm-mm. I don't understand about the wrapper. But one thing I understand that we have to testify this thing. Okay. So let's copy. Okay, sorry. Let's copy this here and paste here. What we have to do is uh, we haven't created a class, right? Retry orchestral choosing. So this is a system design question we are solving here. Okay. Let R2 equals to new orchestrator, and what we are passing is max retry limit is 3. Okay, so we have been given the 3. After that we have to do is create a sync function run, and here we are running this thing. What we have to do is here is await r2 dot uh, instead we can do engine, right? Let's go better with engine. This is a better keyword we are having engine. Just a second, we are completing our system design level 4 boss level question, and let's just execute it. Execute uh, with retry. So have you practiced any system design related questions? Mention your comment, we will love to see. Okay, so now we are passing this, and let ans equals to console.log ans. Okay, now let's run. So this is a new thing actually for us also for managing this thing. uh, Set promise wrapper. Promise wrapper, what we can do is here promise wrapper uh, inline set time out. This is the inline set timeout that we have been created for durations in. Okay, this is should to be expo, right? Multiply by that seconds. Mm, 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 mm. And I think so this should be present here, not here. Okay, so good. Let's run this. What we can, okay, we got retries is not defined. Why it is not defined? Max retries. Okay, we forgot the this dot. Inside this we have to mention, indicate the variable to with this, so it can be easily understand what it is about. Data recovered successful, data attempt failed, 0 backing of 10,000 second. Okay, if it is failed then should log out, right? Where we get it wrong here? Let's just see. It didn't fail, right? Simulates an API that fails twice and finally succeeds the third try. But here we are seeing that their attempt is failing for third. It's a little bit complicated done here like this. Let's check. Create a retry orchestra. Okay, created. Constructor accept a maximum retries. Then implement a public asynchronous method call. Done. Inside that it has a accepting a API callback. Done. Resilience logic. Use a standard like for or while loop that returns up to max retry times. Started from 0 and it's go up to max less than max retries. Okay, done. Inside the loop await callback, we are doing a callback. Okay, I got it. It's not inside, it should not inside the loop actually. What we have to do is, this is the outside thing, I think so. Yeah, I remember. It should not be the inside the loop. The loop is just carry on like this. So what we have to do is, if it is succeed, return. So if the return, if return is a successfully, then it will be returning. Okay, yeah. If it catches array, it catches the array. Okay, so what it has to do, if it has if you have reached the max retries, so if it is max retries, sealing the exit loop. mm, Maybe not, I think, don't so. Let's take this dot max retries, this dot max retries. I don't think so. Let's review our question solutions. Uh, Review our solution. Let's understand by the AI only, because here it's create too much confusion. Your approaches in implementing exponential back of logic is highly logical. Your loop architecture correct. Register the retry ceiling and your guard causes safely monitor. However, your code has a major architectural bug regarding time delays. If you run the exact code, it will bypass all the delays and execute instantly if less than 5 milliseconds instead of backing off. Yeah, we can see that we didn't have a backing. The crucial flaw is non-blocking timer. Critical bug expo. Mm-hmm. Why it fails to delay, fire and forget the mechanism. Native browser Node.js set timeout is asynchronous and non-blocking. Calling it simply a hand and tags over thread timeout uh, tells the code immediately. The instantly loop interruptions because you did not use the await keyword to pause the loop. Okay, for loop and spinning instantly. Attempt pointer lock. You initialize the set attempt 0 top, but you never actually increment. Yeah, I forgot to increment also. How seniors engineer write the blocking delays? Okay. Yeah, I was thinking about this thing. Okay, let's understand and learn from here only. Let's sleep. So what we are doing is here is a set timeout, creating a set time. New promise resolve and resolve, and it should be set time out. Let's learn and practice. We are resolved and we'll be passing the MS. So let's just understand what this is happening here is promise. We have to return a new promise which has a parameter which we will be resolved directly. If we go for a simpler version is like this: ms create an anomalous function here. Okay, after anomalous function it return a new promise here. Okay, and promise has a parameter resolve. Okay, after then it's just return the set time out, and that we are passing resolve. Apart from the resolve, we are passing the here what we ms got here. So this is the simpler version we can do is okay. So but understanding we got this. So just it will be okay. Retries constructor API callback, uh, max retries, attempt, okay, return rest, it's correct. If the I is max retries, throw new error, it's also correct, okay. Uh, Back off calculations, that is expo would be created, max dot pow, and it's not attempt, it will be like I because we didn't increase this thing, okay. And it will be attempt, not attempt, it will be I plus 1 and failed backing off, back off delay, which is our expo, okay. And here rather than this, we have to do is just wait and sleep, and here we will be pass expo, that is our back off, right, back off delay. And now we can see attempt 1 failed, attempt 2 failed, and data recovery. So we are actually correct, but just some of the flaws that we didn't get connected. So yeah, if we think little more critically, we can able to solve this thing also. What changes in your console output is attempt 1 failed, attempt 2 wait for pauses, and attempt 2. The terminal pauses completely 2 seconds and it runs the attempt 3 database recovery. Okay. So you have graduated system design architecture hero. You have a designed and written the pro fundamental production engine, connection pool, circuit breaker, and load balancer retry orchestration. Now you have the mastered the asynchronous oops and low level system design layout. Would you like to build explore next? After next we have what we have. Should we see how drive a real browser UI by connecting these classes to DOM manipulations and even architecture? Should we deep dive into the core mechanism of functional memory management using closure and lexical scopes? Okay, for now we are stopping here only, and we will be continue with the next session. But we will be more practicing like this questions for the system design, rather moving forward with the DOM manipulation and even architecture or a closure. We are more stressing out into the low level system designing. We will also checking the high level, what is the difference between low level and high level things, and what are the core concept of a system design, how can we can understand and scale up the things more interestingly. Okay, thank you for watching us, and we will meet you in the next session. That's it for from the coding bits mid in the section. That's it for now.